Welcome, everyone. And I want to thank, first of all, Ashe, Maria, and Anok for really inspiring presentations, but also for joining me in this conversation. And I also want to thank all of you attending this evening, and particularly in advance for questions which you can share by using the Q&A button that you will see at the bottom of your screen. I'm going to ask the questions to start the discussion, and then we'll field questions from the audience as they come in. Let me start actually first with a question, Anok, for you. Someone wrote in during viewing your presentation and asked, how can we best help your village and the other indigenous peoples of Alaska who are being impacted by the harsh effects of climate change, particularly the swift erosion events which you described?
Thanks, Marty. So thank you for your question. Over the last few decades, there have been people all over the world who are interested in helping many villages, Alaska Native villages. And usually what I tell people when they would like to help, I remind them to go to where they're from, wherever they live, and find out how they can, on a local level, mitigate or adapt to climate change there. Because what people do locally all around the world in their homes will benefit us. I also recommend for people to recognize that as Indigenous people, when we partner with allies, we desire a reciprocal relationship that acknowledges our Indigenous knowledge as equal to Western science. And we like partnerships where we have a say in how we envision our communities. And finally, I would say, for those who want to help Alaska Native communities to be involved in policy and law that directly helps Alaska Native or Indigenous folks relocate safely and do so in a manner that protects human rights and our sovereignty. Thank you.
Thanks, Anok. That's a great response. And I think you've really brought a very bright light to an important issue, and I'm sure everybody appreciates that. Maria, I want to toss a question to you that came in as well as you were presenting. Question is, isn't there already enough renewable energy technology, solar, wind, geothermal, to solve climate change? So don't we just need public policies and political will to get to this?
Yeah, well, actually, I'm really happy that that question was asked, because a lot of people think that, but those of us at MIT realize that in fact that isn't the case. So our energy initiative individuals have done studies, but others have done studies as well, showing that there's greater and greater penetration of renewables into the energy system, but it hasn't penetrated everywhere. And even when we get full penetration, there are still baseload problems. What do you do when the sun isn't shining? What do you do when the wind isn't blowing? Battery technology continues to improve, but there's no guarantee that there aren't going to be gaps. And so the goal, of course, is to achieve a zero carbon energy system. And we usually use a goal of 2050 for making that happen, to avoid the worst effects of climate change. And so our students, not surprisingly, are pressing us to declare carbon neutrality. And so what we've said to our students, what I tell them is, I don't know how to do that. Once you get to about 80 or 85%, it's really, really, really hard to get the last 15%. And so we, the last several years, we've run a class on it, and we said, we don't know how to do it, but students tell us how to do it. And the students find the same thing that the mighty studies have found, is that renewables are going to continue to penetrate until about 2040 or so. And then you just can't do anything more with renewables. You've gotten as much penetration as you can get, and you need to do something else. And for the students, it's a little bit of a, they all of a sudden say, well, it's got to be nuclear fission, it's got to be nuclear fusion, it's got to be biofuels for heavy transportation. So the answer is that we need plenty of new technology in storage and the grid, and in energy sources in different sectors. And we're never going to get to zero carbon without new technology.
Thanks, Maria. That's great. And I guess I think we're all pretty confident that if we do need public policies and political will, that having you in PCAST advocating for these important issues will give us all a lot of comfort. Akshay, I think you got people's attention with some of the technologies you hinted at, and one of the viewers wanted to ask if you could tell us more about the battery technology that you're developing in your lab.
Yeah, sure. So we call it a battery because at the end of the day, it takes in electricity, stores energy, and then puts electricity back on the grid when you want it. But what's rather unconventional about it is we're not storing the energy electrochemically the way you would normally store energy in a battery. We are storing energy thermally. So my expertise is in heat transfer. And so one of the main benefits of heat is that it can be very, very inexpensive. And so what we do, if you've taken a thermodynamic class, it'll sound like a thermodynamic crime to do this. But basically, we take electricity, convert it to heat, which would seem dumb because we pay a huge penalty converting heat to electricity the first time. So to now go back to heat, only to go from heat, which is then stored, back to electricity a second time and pay the penalty a second time, would sound like a bad idea. And from an efficiency standpoint, it is, but from a cost standpoint, you actually win. And the reason you win is because storing heat can be like 100 times cheaper than storing electricity electrochemically. And where this essentially comes from is the fact that when you build a normal electrochemical battery, you have to have materials in certain locations, and they have to be pure, and you're trying to prevent side reactions and things that ultimately shorten the lifetime of the battery. When you store energy thermally, you're literally storing energy in like the kinetic energy of the atoms. So they just literally move around faster, they speed up, and that's the equivalent of it heating up, and then they cool down and they slow down. And so that process rather intrinsically has, almost effectively infinite lifetime. So there's no real degradation mechanism in the system we're envisioning. And so what we do is we store heat in an extremely cheap medium. In our case, it's graphite, and it's about 50 cents a kilogram. And so when you work it out, by comparison, we're taking electricity in, storing it as heat at extremely high temperatures, up between about 1900 degrees Celsius and 2400 degrees Celsius. So glowing white hot in graphite blocks, which work out to be about $10 a kilowatt hour, compared to batteries, which are over $100 a kilowatt hour. So it's about a factor of 10 reduction in cost. And that reduction in cost ends up outweighing the penalty you pay on the efficiency in converting back. And we do the conversion back in a way that's very different than normal. Usually you convert back with a turbine or some kind of heat engine with moving parts. In this case, we went to such high temperatures so we can do the conversion back actually with photovoltaics. So we actually have photovoltaic cells specially designed that actually convert the light being emitted off of that hot infrastructure, and that's how we get electricity back. So those are kind of the key elements. If you Google sun in a box, you'll find some articles and a paper about it. And so those are kind of some of the key elements that describe how the technology works. I wish I had time to pull up a figure and walk you through every step, but those are the basic ideas.
That's great. Thanks for sharing that. As I'm listening to you talk and also listening to your presentation earlier, I kind of wish that I'd had you as my thermodynamics instructor in college. Anouk, I want to go back to you. A question that was asked was sort of beyond language preservation, what advice can you give to others who would seek to sustain their cultures in the face of environmentally driven displacements?
Thanks, Marty. So what I immediately think of in terms of sustaining culture in the face of environmental degradation is be creative in the way you sustain your relationship with the earth and the foods that you eat and the water you rely on. And, you know, Indigenous peoples have figured out how to live sustainably, right? The buzzword sustainability. And, you know, as an Inupiaq woman, seeing my community, since we rely on the land for our food, for our spiritual wellness, for our identity, it becomes very problematic when land is literally being lost. And so we often say that our relationships, our relationship with the land is changing. And, you know, I think being able to be creative and reestablishing your relationship with the land in different areas, you know, primarily that is like the foundation of Indigenous culture. And so, you know, I think as humans, all of us need food and all of us need water. And if we can't protect the land and the food and the water, that means it's game over for all of us. And so that's what I would encourage. And I meant to say earlier, in terms of how I can imagine others assisting Alaska Native communities, is you know, there's so much talent at MIT, and there is a huge focus on engineering. And one of the visions I had was to create some sort of program, like an engineering pro bono. Instead of pro bono lawyers, you'd have pro bono engineers, and engineers could go to Alaska and help build homes for villages who are losing their lands and have to relocate. But not only build homes, but teach the local communities how to build their own homes. So there's a village in Alaska, there's a picture that was shown of Newtok, and that is the village that's furthest along in their relocation. But not all homes have been built yet, and not all funding has been found to build those homes. And one of the leaders in Newtok, what he did before they moved most of their homes was he brought young students to get trained in all sorts of different trades, so they could be the ones that were actively building their new communities. And so I'm just putting that idea out there. I really, you know, I'm graduating in May, but I really think that there's a lot of potential for the intellect and the talent at MIT, and I would be happy to take folks out to my community and foster a reciprocal relationship.
Thank you, Anouk. That's a fantastic response and such thoughtful remarks. Thank you so much for that. Ashe, let me go back to you. Another question that was just posted was, does the emphasis on the need for interventions at the global scale mean that individuals' actions to reduce their carbon footprint don't matter?
I think that they definitely matter. I mean, I think there's a bunch of personal choices that we make that can have some significant influence. But I think that the largest and most significant problems still rely with the collective, with large entities that are largely responsible for the major gains, the major changes that we have to make. And so, although, yes, I mean, I think, for example, everybody should replace their incandescent light bulbs with LEDs and things like that. These are personal choices that, yes, everyone can make that will lessen the electricity load. People should think about switching to electric cars as opposed to gasoline-driven cars, things like that. Those things can definitely have a significant impact on a very personal level. If you see a large movement, a large massive amount of people starting to make those individual decisions, it adds up. But in the end, I think at the end of the day, is there anything that any individual can do to decarbonize the steel industry or the cement industry? I think those things require more of a collective effort and a bigger effort. So it's definitely not true. I would definitely not say that there is nothing or that things that individuals do will not have any impact. But I think that part of the individual impact you can have is also by word of mouth and infecting others with these ideas and getting a greater number of people to make personal decisions that can have an impact.
Great, thanks for that. Maria, I want to go back to you. It's an interesting international question, which is basically, what can we do to influence and work with other major carbon dioxide emitting countries like China?
Yeah, that's a great question. So, first thing we did, President Biden on Inauguration Day rejoined the Paris Agreement, which set the course that the United States again is being a participating international partner, recognizing the need to decarbonize. There's a lot of talk. Let's talk about China specifically, since they're such a major emitter. They're really out in front in terms of renewables, but I think one of the questions that came up, indicated that they're still building coal plants, which they've got an economic development area on the Belt and Road, which is to bring development to parts of China that have not had it before. So part of if there's anywhere where we ought to be working together with China and every other country on earth, it's in the areas of understanding climate and developing clean energy solutions. And the reason that China's building coal plants is for economic reasons, that it's the cheapest feasible energy that they can put there. But if there were a different option that was affordable, they would use it. That's certainly the case in developing countries, in countries like India, where coal is really cheap, and we've got to come up with a solution that is comparably cheap for people to adopt it. So the key is that we don't have a one-size-fits-all solution for even different parts of the United States. It's different if you're on the coast as opposed to the Great Plains, and it's different if you're in China or India or South America or Africa. And so we need a range of solutions, and we need solutions that work for those areas. And so we ought to be taking a lead in developing these technologies, but we ought to be collaborating with these countries who also have a lot to offer. And I just want to I think close this by saying that I talked with a head of state in Africa who indicated that the developing world needs to be a part of the solution. We don't want to sit there and wait for somebody to bring an answer to us. We want to be part of developing those solutions. So actually, one of their undergraduate students just finished a PhD at MIT and is going back to the country to start developing those solutions. So we can do it by education, and we can do it by collaboration.
Thanks, Maria. We've got just about 3 minutes remaining, 2 or 3 minutes remaining. So let me go to a final question, and I'd like to invite each of you to reflect on this one. And that is, lots of concerns globally and in the United States and in academia about this global crisis. But what do you think is unique about MIT's ability to tackle this crisis? So let me, Anouk, would you feel comfortable responding to that question?
Sure. I think what's exciting about being a graduate student at MIT is the connection I have with people from all over the world. And one thing that I'm seeing come up in conversation more is this idea of a just transition. And really what that means is, it's often it's often people of color or those that experience are on the front lines of experiencing climate change. And I think it's important that MIT sends a message throughout the scientific community that these technologies that are developed must be in partnership with those on the front lines, including Indigenous peoples. And I would really love to see partnerships with Indigenous knowledge and Western science to enhance the response to climate change. So these are some of the conversations I've been having, and I would love to talk more with anyone interested in that.
Thanks for that. Ajay, do you want to take a shot at that question? What you think makes MIT unique in this global crisis?
Yeah, I think what I would say makes MIT unique, when you think about climate change, you think about maybe just one aspect of reducing CO2 emissions. I think one of the key things to realize is that what has to happen is an intersection or change in business. Like we always talk about business as usual. And then there's also the technology piece. And I think MIT sits at a really unique position in being one of the premier institutions on earth that has a very integrated and streamlined process for technology to integrate into businesses, and has relationships between technology developers and business. So I think the ability to have partnerships and also transition technologies quickly and effectively and efficiently is one of MIT's unique unique points that MIT brings to the folks.
Great, thanks for that. So Maria, I think we lost you for a second. All right, well, we were speculating that maybe the other president you worked for might have pulled you out. I think we'll have to wrap up, Maria, but thanks to all the panelists for the great remarks, and thank you for those attending for the really stimulating questions. We hope you'll stay and participate in the next round of breakout sessions. They're set to begin in just a couple of minutes. And to find the next session, please navigate back to the event page and choose the session you would like to attend. Please enjoy the rest of your evening.